Namaskar, my dear friends. Let us talk about GATE mathematics. So, what we have seen till now is probability. Now, we'll start with random variables. So, this mathematics syllabus is applicable for most of the branches like EC, EE, IN, ME. Okay. So, what we'll start with random variables is what is random variables, what are the different types, on different distribution kind of thing. So each of them are very much like important because most of the questions are being asked in random variables from this topic. Okay, so let us see first what is random variable. Random variable is a mapping from sample space S to R. What does it mean is, let us say you have a sample space. Let me give you one more thing. Random variable are denoted by X, Y, Z. Basically, like capital letters, it is denoted. Okay, so let us say what is sample space we'll talk about. Let's say we are going to toss two coins at a time, or a coin tossed two times. Okay, so both are same. So you can see we have sample space is equal to either it can be head head, head tail, tail head, or tail tail, right? Now we are going to consider a random variable which is x, which is going to represent the number of heads. Okay, so if x represents the number of heads, then what will happen? I can say I can say very easily that my different like options are what? Tail tail, tail head, head tail, or head head. So in this head tail and tail head, both are having only one head. That's the reason both of them are considered together. Now let us say my random variable x, which is going to represent the number of heads. Okay, so that is going to represent how many heads are there in this one? 0. In this one, 1. In this one, 2. So two number of heads are here. Can you now tell me what is the probability of each of the options? So let us say probability of xi is going to be total number of sample space were 4, right? Like we had ns is equal to 4. So in that case, you can write down ne by ns, right? So how many times it is appearing? So 0 is appearing one time, that is 1 by 4, then 2 by 4, then 1 by 4. Understood? So basically you can write it down that my xtt is equal to 0 times, 1 time, 2 times. So this is how these two are same. That's the reason it is 2 times. So you can, one more thing you can say here, that every element has a unique element. Okay, every element has a unique image. What does it mean is, basically let us say you have here sample space and you have here range. Okay, so in that case, this is the relation that is going to be represented by random variable x. So we have sample space, let us say tail tail, tail head, head tail, and head head. Now what is the possibility that is there? So either it can be 0, 0.5, or 1 or 2, any real numbers you can have in this range. So 0 times head is how many? 1. 0 times head is 0. Then tail head and head tail both are actually single 1, right? So you can say this one or this one, both are same. Then this guy is 2 times. Okay, so how many heads are appearing in this random variable? So you can see tail tail is having 0 heads, tail head or head tail is having one head, head head is having two heads. Okay, so this is how it is mapped. Now let us talk about types of random variables. So you can say there are there are two types of random variables. Okay, number one is discrete random variable, this can also be written as, let us say, DRV. So discrete random variable is what? If x takes only discrete values, okay? Let us say, let us say we have x random variable. So if x takes only discrete values. Discrete values means it is not continuous, okay? So all the values will be discrete. Like you can count them very easily. Like for example, if I take some examples, what is the discrete random variables? So you can say tossing a coin. So you can count them, how many times the coin is tossed, or how many heads are appearing, or how many tails are appearing. So tossing a coin is going to represent a discrete value of random variables. Or throwing a dice, throwing a dice, or you can say a number of defective pieces in a heap, okay? Number of defective pieces in a computer slot, a lot or something like that, okay? So this is how you can represent discrete value random variables, okay? Number 2 is continuous random variable. This can be written as CRV. So what it does, it basically takes the all, like if x is a random variable, it takes all continuous values, okay, or all values between certain limits, okay. So you can say if x takes any possible values between certain limits, let us say a and b. So for example, if I want to find out what is the random variable which represents continuous random variables, so that can be taken as, let us say, height. Like in a class, if you want to find out height of all the students, it can take any values, you are not sure about it, okay? So that is how. Then you can take weight as well, or you can take age of students in a class. So all these are having one value, but they are continuous because we are not sure about it, what can be there, okay? Or you can say what is the amount of rainfall, or what is the temperature of the environment. So all these things you can take in this example. Let us say rainfall or temperature. So all these are examples of continuous random variables. Now, we are going to talk about most important parts, which is called as probability mass function, cumulative probability function. So because all these things are like PDF, CDF, all these things are very much useful, okay? So let us talk about probability mass function. Probability mass function, okay? So let us say a function f of x or p of x is said to be PMF. A function f of x is said to be PMF, like probability mass function, if number 1, my probability of x I is greater than equal to 0. Basically what I mean to say, for each I. So any element you take xi, its probability must be greater than or equal to 0. Okay. Then second one, this is very definite. summation of all the probabilities of each element must be equal to I equal to, let us say, 1 to n, must be equal to 1. Okay, it means the addition of all the probabilities we had seen just now, this was the random variable, this was the random variable x, and you can see probability of xi, if you sum them up, you will get 1. Okay, so whether it is 0 head or 1 head or 2 head, if you sum them all, it means it will give you 1. That's the reason it is a random variable. Okay, now let us talk about cumulative probability function. Okay, so this PMF, that is probability mass function, is also called as probability density function. Now talk about cumulative probability function. Cumulative probability function. Okay, so what it says is, it is represented by capital F. Okay, so capital F x is equal to xi is basically equal to summation of all the probabilities. Okay, summation of all the probabilities having random variable which is less than x equal to xi. Okay, so either this x equal to xi means up to xi you have to take all the probability summation. Okay, so let us say tossing two coins, x represents number of heads. Okay, you had seen just now. Tossing two coins, let's say x is a random variable, represents getting number of heads. Now if I tell you what is my f x equal to 0, it means summation of all the probabilities up to getting head 0 number of times. Okay, so that is going to be px equal to 0, that is 1 by 4. If I tell you probability of x equal to 1, like cumulative probability function of x equal to 1, that is going to give you px equal to 0 plus px equal to 1, like that. And it means you are going to get what? You are going to get very nicely here, this is 1 by 4 plus this is 2 by 4, that is going to be 3 by 4. Got it? If I tell you x equal to 2, it means probability of getting 0 head plus probability of getting 1 head plus probability of getting 2 head. Because up to 2 we can add them up. That's the reason I'm telling you this is going to give you 1 by 4 plus 2 by 4 plus 1 by 4, that is 1. Understood? Now let us talk about, you have understood like what is my cumulative probability function. Now let us talk about continuous random variable in A to B. Okay, continuous random variable. Got it? So basically basically what I mean to say is let us say we have two numbers a and b, and you can say that you have a function between a to b like this. Okay, so this is my y equal to nothing but f of x. So this function f of x is going to be my probability density function. Okay, so basically what is going to be written here is probability density function, probability density function, or it is called as PDF. Okay, f of x or p of x. Sometimes we represent it by a small f of x or a small p of x. Okay, is said to be PDF is said to be PDF if what are the conditions? My f of x must be greater than equal to 0, just like probability mass function, okay, for all x. And number 2, you must understand the summation was 1, right, in probability mass function. Same way here, this a to b f of x dx must be equal to 1. It means this particular function, if it is representing probability density function between the interval a to b, then it must give you a to b f of x dx equal to 1. So then only it will be called as probability density function. And from here you can get cumulative probability function as cumulative probability function. This is going to be f of let us say x less than or equal to some t, okay. So how will you find out? You have to find out from the same function f of x cumulative probability function. So that will be a to some value t, and this t can be any value between a to b, okay. So let us say up to t you want to find out cumulative probability. From here a to t you have to sum them all, or if it is continuous you have to integrate them all, like that. So it will be f of x dx. Understood? So hope you have a good understanding now that f of x less than equal to t is going to be equal to a to t f of x dx. So now I'm going to represent, I'm going to give you some properties of continuous random variable and discrete random variable. You can make a note of them, okay. So for discrete random variables, what are the things that is there is probability of a which is less than x less than equal to b can be also written as cumulative probability function at b minus cumulative probability function at a. That's all. So f of b minus f of a, if you find out, you will be able to find the probability between a to b, any two numbers, okay. Similar to that, if it is equal, like probability a greater than equal to less a less than equal to x and x is less than equal to b, this will also be same, which is going to be probability of x equal to a plus cumulative probability function at b minus cumulative probability function at a, okay. And if you represent like this, let us say probability of a less than x less than b, I want to find out. So what will happen? You will be finding probability of probability cumulative probability function at b minus cumulative probability function at a minus probability at x equal to b, because you do not want to include equal to b, right? So this is for discrete. Are you getting it? You want to include x equal to a, that's the reason you have added probability at x. Similar to that, here you do not want to include probability at b, that's the reason you are excluding probability at b, okay. Next, last one will be what? Probability of a less than equal to x and less than b. So it means what will happen? This will be probability mass function at b minus probability mass function at a. Now you are going to add at a. So you can add plus probability of x equal to a, and you are going to subtract at b minus probability of x equal to b. So this is the four relation that you can see based on uh, less than or less than equal to or greater than or greater than equal to what will be the cumulative probability mass function relation, okay. So this is for discrete. Now if you talk about continuous, so continuous is very straightforward. Continuous is not that much complex. for continuous random variable. We have probability a less than equal to x less than equal to b, okay, is actually equal to all. Like it can be equal to probability a less than equal to x less than b, or probability a less than x less than b, or less than equal to b, and then probability a less than x less than b. So all are equal, and it can also be found out very easily. A to b f of x dx, and this is going to be all equal to f of b minus f of a. So there is not much like a problem whether it is equal to or not equal to, doesn't matter. If it is probability of a less than x less than b, it all are equal, okay. Whether a is included or not included doesn't matter, because it is continuous. All right. Now let us take next concept. The probability of continuous random variable at any point is 0. Okay. The probability of continuous random variable at any point is 0, where you know already differentiation of cumulative probability density function f of x is going to be equal to my PDF, probability density function. So if you want to find out what is my PDF from cumulative probability function, you will be able to find out very easily. Now let us find out what is expectation, mean square, standard deviation, variance, everything very nicely. So why don't we do one thing? You can say I will write it down something like this. Here discrete and here continuous. And let's say I'm going to give range A to B. Okay. So now number one, we can say expectation. Expectation is represented by E of x. So this E of x, or it is also called as mean, okay? Mean. This is represented by mu, okay? So this can be found out in discrete summation 1 to n xi into pxi, okay? So if you want to like find out expectation of any like PDF or any random variables, this will be xi into p of xi. You sum them up to n. Now in continuous, what will be the expectation is, expectation will be a to b. See, CDF I had found out f of x dx, but for expectation you have to do x into f of x dx. Got it? It's very simple, and this is very important. You mark it star mark, okay, because this is the equation which is being used several times, okay. Number two, mean square value. So this mean square value is represented by E of x square. This can be found out by summation xi square into p of xi. Okay, and in continuous it will be found out by a to b x square f of x dx. So I'll give you a understanding, like let's say you want to find out e of x cube or e of x to the power n. Simply you have to do x to the power n f of x dx. That's all. Up to 2 or 3 some numbers and some names are there, like it is mean and it is mean square, then there will be like a cube, all these things will be there. However, that doesn't matter. A very simple rule is, if it is a square then you have to do x square, if it is cube you have to do x cube. Okay. Number third is variance. Variance is represented by, let us say it is written as V of x, okay. So this V of x, it is also written as sigma x square, okay. So this can be found out, expectation of x square minus expectation of x ka whole square, okay. And sometimes this x square is called as m2 minus this is called as m1, so m1 square. So this is how you can represent variance is equal to m2 minus m1 square, or more easily you can represent expectation of x square minus expectation of x whole square, and this is applicable for both discrete as well as continuous, okay, because both are having expectation of x square. So you find out and then you can write it down. Next is fourth one, which is going to be a standard deviation. This is represented by sigma, and sigma is going to be equal to plus minus a square root of variance of x. So you have already found out what is your variance by this formula, and from here you will be able to find out a standard deviation sigma, okay. Let us solve some questions so that you can have a proper understanding like how to get all these values, okay. So let us say the question is, the following table shows the probability of discrete random variables. Following table shows the probabilities of discrete random variable. Find the standard deviation of random variables. Find the standard deviation of random variable x. Okay, so the table is written as x 1, 2, 3, and probability is also given as x equal to x, which is 0.3, 0.6 and 0.1. So first of all, you have to understand, just try out if you can do by yourself. Take a moment of time and try to solve by yourself. Let us see. First of all, you have to decide whether it is a probability density function or not. So you can see the summation of probabilities are zero point 0.3 plus 0 0.6 plus 0.1, that is going to be 1. So you can see summation of p of xi is nothing but 0.3 plus 0.6 plus 0.1, that is 1. It means it is a probability density function PDF, okay, that's all. Now let us say we want to find out a standard deviation. So to get a standard deviation, what is that? We need sigma, which is going to be plus minus a square root of variance of x, right? Now the problem is we do not know what is variance. So variance, you have to find out variance is equal to expectation of x square minus expectation of x whole square. So for that we need to find out expectation of x and expectation of x square both. So you already know that what is my expectation of x. So that is also called as mean or expectation of x is going to be equal to summation xi into p of xi. So can you write it down? What is my xi and p into xi? So xi is this one, 1, 2, 3, and p of xi is corresponding probabilities, okay. So to do that we can write it down 1 into 0.3 plus 2 into 0.6 plus 3 into 0.1. So from here we are going to get, what is that? And 0.3 plus 1.2 plus 0.3. So that is going to give me 12 3 15 3 18 1.8. Okay. Now expectation of x square we want to find out. So that will be what? Summation of xi square into p of xi, that you know. So to get this, what we can do? You already know 1 square into 0.3 plus 2 square into 0.6 plus 3 square into 0.1. So to get this 0.3 plus 2 दूना 4 6 24 2.4 plus 3 3 जा 9. That is going to give me how much? 9 2 11 11.7. Wait a moment. Uh, this is 3 3 ja 9 into 0.1, that is going to give me 0.9. Okay, 0.9. So this 0.9 plus 2.4 plus 0.3 is going to be how much? 9 4 13 3 16 3.6. Okay. So what will be my variance? My variance V of x will be equal to expectation of x square minus expectation of x whole square. So that is 3.6 minus 1.8 whole square. So that is going to come up as 3.6 minus 18 18 324 3.24. So that is going to come up as how much? 0.36. Now what will be my standard deviation? So standard deviation will be equal to square root of variance. So square root of variance. So that is going to give me a square root of 0.36, which will be plus minus 0.6. Okay. So this is how a standard deviation you have found out from the given random variable. Hope you have a good understanding of like how you have calculated step by step your standard deviation from the expectation and expectation x square, and then you got the result variance, then standard deviation. Okay. Let us take another question. The question is the 9 words of the sentence the 9 words of the sentence, these were asked in GATE. The quick brown fox. This is very like popular statement to make you write and learn like all the letters of the alphabet. So the quick brown fox jumps over the lazy dog. Got it? Are written on a separate piece of paper. Separate piece of paper and kept in a box. If a piece of paper is selected randomly, if a piece of paper is selected randomly from the box, the expected length of the word on the paper is the expected length of the word on the paper is. So basically you can see there are 9 words: 1 2 3 4 5 6 7 8 9. each of them is written in on a sheet of paper separately, and you are going to select any one paper of them, right? So one paper, if you take it, what will be the expected length? Means basically they are asking you mean length. Okay, so this is also a random variable. So let's solve it. Or if you want to try by yourself, you can try by yourself first, and then we will you can see the solution. Okay, so let's say x represents my random variable, defines the length of word. So what will happen? My x equal to xi, which is going to be giving you the length of word, and I want how many number of these events are there. First we'll calculate, and then we'll find out probability of x equal to xi. You can always write without writing any, also you can write down probability, but I want to just make sure I don't miss anything. Okay, so for that purpose, what will happen? Let us see. X equal to xi. So what is the least number of like letters in the word? So 3 3 3 3. So total four are there with 3 letters. Okay, so 4 numbers, 3 1, and then 4 letter word, 5 letter word. 5 letter word is the maximum, I think, right? Now 4 letter words are how many? 1 2. And then 5 letter words are how many? Quick, brown, jumps. So 3 are there. So total you can see 4 plus 2 6 plus 3 9. Total 9 words are there. So what is the probabilities? 4 by 3, 2 sorry, 4 by 9, and then 2 by 9, and then 3 by 9. And you can see 4 plus 2 plus 3, that is 9 by 9, that is 1. So probability is 1. So the x represents a random variable. Okay, and you can write it down if you want. Number of sample space is nothing but 9. Now I had told you the expectation of x is nothing but summation xi into p of xi. So this is going to be very simple. Can you write it down? What is my xi? Xi is nothing but your 3. Okay, so 3 into its probability, 4 into its probability, 5 into its probability. So you can write it down quickly. 3 into 4 by 9 plus 4 into 2 by 9 plus 5 into 3 by 9. And by doing this, you are going to get very simply your expectation, which is going to be 12 by 9 plus 8 by 9 plus 15 by 9. So that is going to give me 9, 12, 8, 20 और 15, 35. 35 by 9. This is going to give me how much? Approximately 9 या 27, 9 8 72, 9 8 72. So approximately it is going to be equal to 4 letters. Okay, because letters cannot be decimals in the word, so it will be 4. So basically the expectation of the words that you are getting on the piece of paper, that will be 4. Let us take another question. This was asked in GATE EC. So the question is, a discrete random variable x takes the values from 1 to 5. From 1 to 5 with probabilities given below. With probabilities given below. It is written like this: x and probability of x equal to xi. Understood? So it can take 1, 2, 3, 4, 5. This is the random variable that is taking the values, and their probabilities are 0.1, 0.2, 0.4, 0.2, and 0.1. A student calculates the mean of x. A student calculates the mean of x as 3.5, and his teacher calculates the variance and his teacher calculates the variance of x as 1.5. Okay, which of the following statement is correct? So we have to find out which of the following statement is correct. Options are student right but teacher wrong, but teacher wrong. B is teacher right but student wrong. C, both are wrong. And D, both are correct. So it is a competition between a student and teacher right now, you can see, right? So your aim is to find out what is the expectation and what is the variance, okay, both, and then see whether it is 3.5 and 1.5 or not. Then we can decide which one is wrong and which one is right. Got it? So it's very simple to calculate. We have the probability density function from here, and you can see the addition of these probabilities are actually 1. That's the reason x is a random variable. Like you can see 1 plus 2 3 plus 4 7 plus 2 9 plus 1 10. So one probability is 1, right? So let us calculate one by one. So my solution would be very simple question. You know already my expectation, which is nothing but your mean. Mu is equal to expectation of x is going to be summation of xi into p of xi. Very simple. Now to do that, you are going to get how much it is? 1 into 0.1. You don't have to write all these values exactly. You can directly multiply and write it down, okay? But I am writing it for your understanding. So 2 into 0.2 plus 3 into 0.4 plus 4 into 0.2 plus 5 into 0.1. So that is going to be 0.1 plus 0.4 plus 1.2 plus 0.8 plus 0.5. And that is going to give me how much? 4 एक 5 2 7 8 15 5 20 and 2 एक 3 3.0. So you can see my expectation has come 3. It means a student is wrong, right? Now what is my expectation of x square? Because we need to find out variance, and for variance we need expectation of x square as well. So that is going to give me how much? Summation of xi square into p of xi. So for that I am going to do 1 square into 0.1 plus 2 square into 0.2 plus 3 square into 0.4 plus 4 square into 0.2 plus 5 square into 0.1. So you can say that this is 0.1 plus this is 4 दूना 8 0.8 plus 3 तिया 9 चौका 36 3.6 plus 4 चौका 16 दूना 32 3.2 plus 5 बजे 25 into 0.1, that is 2.5. Now if you add them up, how much it is going to come? 3 2 5 2 7 7 and 8 1 9 6 15 2 17 5 22. So 8 और 2 10 10.2. Now what will be the variance? My V of x is going to be equal to expectation of x square minus expectation of x whole square. So that is going to give me 10.2 minus 3 square, because 3 is the expectation. So this is going to give me how much? 10.2 minus 9, that is going to come up as 1.2. So you can see the expectation is 3 and variance is 1.2, and both teacher as well as student both are wrong. Okay. So you can say both are wrong. So alright guys, what we'll do is we'll solve much more question, because there are ample amount of questions that has been asked in GATE based on this particular topics. So you can keep it right now and we'll proceed in our next session. Thank you.